Okay, right now we're going to deal with translations of a quadratic function. And this particular graph that we're looking at right here is y equals x squared. Sometimes we'll see that in function form. It'll say f of x equals x squared, or g of x equals x squared. And the graph here is pretty accurate. I mean, it's a little bit of human error when I try to draw it. It's a little bit wavy, but you kind of get the picture of it. And what we're going to be dealing with right now are the translations, how this particular graph is going to shift up or down, left or right. So let's look at, first we want to look at what our vertex form of an equation looks like. And here is our equation for the vertex form. And it's real similar to the one that we've got, just the y equals x squared. It's got an a, it's got an h, and a k. And so we're going to talk about the h and the k, what we're going to focus on this video. The h on this one, right there, is our horizontal shift. So we're just going to say HS, our horizontal shift. And what that basically means is how much this graph moves side to side. Okay, and then the k in this case is our vertical shift. So we'll go VS for our vertical shift. Okay, so, and that basically just means how much is this graph going to move up or down. So let's go through an example right now, and we'll write one here. Y equals x minus 2 squared minus 4. Okay, so what we want to determine here is we've first got to identify what our h is. Now up here it says x minus h. Right here we have an x minus 2. So h in this case would be 2. So h equals 2. K up here, it's our last term over here, the constant term in this particular one. So the last term here is going to be a negative 4. So that means that my k is going to be negative 4. Okay, so now we're going to look at our shift here. We've got our original graph right here, this black one. Now I'm going to place another graph here that looks identical to that one, only we're going to do it in green. If you'll notice, I'll just line these up and it's the same graph. Nothing's changed there. Only it's just green, just to differentiate between the two graphs. Okay, so on this one, our horizontal shift is h. h equals 2. Horizontal means that we're going to go side to side, and it's going to move in the positive direction 2 units. So let's take this right here, and if you'll pay attention to the vertex right here, that's going to be the big one that will move. It's easiest to see that movement in the vertex. So we're going to take this one, and I'm going to take this graph, and I'm going to move it to the right. There's 1 unit. There's 2 units. Okay, so all I did is I moved it to the right 2 units because my h equaled 2. Now my k equals negative 4, and that's the movement up and down. Okay, so with a negative 4, that means I'm going to move down 4 units. So I'll take this same graph, and I'm going to move down 1, 2, 3, 4. Right there. So what you want to notice on this one is that the graph is actually the same exact size. There's nothing changed there. The negative 2, h was positive 2, excuse me. K is negative 4, so that means that we moved positive 2. We can illustrate that. We moved over 2, and then we moved down 4. Same exact graph. Now, the interesting part with the vertex form of an equation is it quickly identifies our vertex. And our vertex, it's like a little code, is h, k. Well, we know what h is. H is 2, and k is negative 4. So we can write that. The vertex on this particular one is 2, negative 4. Now, if we remember what our vertex is the highest or lowest point on a graph. And so this is the lowest point on this particular graph, and that point right there on the coordinate plane is 2, negative 4. So that is our vertex on this particular one.